going to talk about graphing the reciprocal trig functions. And in order to do that, I first want you to graph y equals sine theta on this graph from 0 to 2 pi. Actually, go out to 4 pi for me. Okay, go 0 to 4 pi, graph y equals sine theta. And then after you do that, I need you to have a highlighter out and your table from yesterday, please. Hey, really quick graphs of them, all right? So when we're dealing with sine, I'm not going to put the whole graph on here to begin with. I'm going to follow my pattern for sine. If you remember the pattern we had for sine, 0, max, 0, min, and 0. Okay? So if I'm here and I'm going out to 4 pi, I hope I gave myself enough room here.
Yeah, it's the very last line is 4 pi.
All right. It's 2. Oops, that's 3 pi.
You put 3 pi over 1.
I could have, yeah. All right. So we go out to 4 pi there. Hopefully you'll be able to see that okay. All right, and I have the 0 max, 0 min, 0. So remember A is 1, A is 1, B is 1. Hopefully it's really easy there. So from 0 to 2 pi, you should see one cycle. So I have my 0, I have a 0, and I have a 0. All right, and in between I have my max and my min. That should not be anything new. Okay, hopefully that was a really quick graph. And I noticed I didn't draw my curve because really I want to graph cosecant. You guys already know how to graph sine. Okay, if you drew the curve, that's okay. I'll actually fill it in here in a minute just so we can all see it. Okay, but for cosecant, we need to think about this table. In fact, you know what? Let me draw on this line real quick so you can see what it looks like. Mostly because Brooks is up here erasing and I just wanted to annoy him.
Thank you.
Okay?
For that, Ms. McCoy.
All right. Anything I can do to help.
Yeah.
All right, so I'll do my best to get that curve drawn in. Did everyone find a highlighter? If you don't have a highlighter, hopefully you at least have one at a table that you can, it could be like a community highlighter.
Too bad I have
Okay, here you go, we got our sine curve. Everyone's focused back up here. Go back to your table here from yesterday. You'll notice on my table, I highlighted those pi's over 4s, those 3 pi over 4, the 5 pi over 4. You may want to highlight those as well. The reason why I highlighted them on this table yesterday is just it kind of gave us road markers to follow. Okay, it just allowed us to see where we were at in the table. Today, pi over 4 doesn't exist on our graph. However, when I'm counting here, what's my interval I'm going up by every time?
6.
Not 6. Pi over 6, right? So when I count by pi over 6, do I ever actually hit a pi over 4 on a line?
Yes.
No. And that's why I have those highlighted. Those are points I won't be using. I'm not plotting today. But I'm plotting all these other ones. Okay? And that may seem like a pretty daunting task, but if I start looking at this and just think of sine, the sine of 0. Now, we have to understand that we're going, here's 0, this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and pi. That's this right here. That's from here all the way down to here, excluding the 2 highlighted parts. Okay, and I'm graphing sine. I've already plotted those. Okay, really I just did my 0, my max, my min, my zeros, okay? But when I do cosecant, I want to actually plot these points. And cosecant goes with sine. It's the reciprocal. Notice when sine was 0, one of our questions last night talked about when sine was 0. Cosecant is undefined. Okay? Now understand that the reason that is because if I have the number 0 and I put that over 1, that's 0. But when I flip that and take the reciprocal for cosecant, that's now 1 over 0. And you can't have 1 over 0. That is undefined. Okay? So every time you see a 0 on your graph, that's where it crosses the x-axis or the theta axis, that's undefined. And how do we show undefined when we're graphing? Volunteer, please. We're keeping score this week. Go ahead, Brooks.
As an
You don't know what that means, but you'll like that. Go ahead, Brooks.
As an asymptote.
Yeah, we do that as an asymptote. Okay, so everywhere on here, we should have an asymptote where we see a 0 for sine. There's an asymptote. In fact, I'm going to draw these in pen here. Maybe you can see them a little better. And here's an asymptote. So to graph the cosecant graph, you got to first start with the sine graph. It makes it a lot easier. That's why we spend so much time. I missed 1 0, and it's right here. It's actually at the y-axis. Okay? All right. Any questions so far? Okay, moving on. So now I'm just following my cosecant here. At pi over 6, I'm at 2. So we go back here. Notice I'm going up by half. Okay, so at pi over 6, this is 1 pi over 6. I'm at 2. So I've got to go up to 2 and put a point. Okay? Now actually, well, we'll do that a different way. Okay? At 2 pi over 6, also known as
Pi over 3.
pi over 3, I'm at
2 root 3 over 3.
2 root 3 over 3. How many of you did those decimals last night? Just on the side of your paper, what is it? Paige? What is 2 root 3 over 3?
I'm pretty sure I did it. What number?
2 root 3 over 3. You're not, Paige.
Yeah.
Go ahead, Paige. What'd you get?
1.15.
1.15. Let's round that to the nearest tenth. What do you get? 1.2. Okay. 1.2. So I'm going to 1 and 0.2. That's about right there. Okay. 1.2. And you'll notice we start getting some repeating stuff. We have undefined, we have 2, we have 1.2, right? So maybe on the side of your paper over here you write 2 root 3 over 3 is 1.2. We have 1, hold on, 1 is right here. Yeah, man. That's where they touch. They touch at the peak there. And then what happens? It goes back up. 1.22. It's like reflection. It's like a reflection there.
Whoa, I see it.
It's a
Total whoa.
parabola.
Okay, it looks like a little parabola up there. Now it's not necessarily parabolic, but looks like a neato little parabola type shape. A little U shape there, okay? I should actually curve it correctly. And I'm hoping you guys are using pencil and not pen like I am. Okay? Don't want you to make mistakes. We've got that. Now you'll notice here, every time you have a peak or a valley, that is a point that your cosecant graph is going to hit. And you'll start seeing repeating patterns now. Like this point right here, this is 6 pi over 6. 7 pi over 6 is 2, or is negative 2. 8 pi over 6, or
4 pi over 3.
4 pi over 3 is actually negative 1.2. And then it hits, and then you get that reflection. So once you've found one set of curve, everything repeats itself. All right, and you can use your table here to help yourself out, but this is going to be the same. We're going to have our 2, our 1.2, our 1, our 1.2, and our 2. And this over here is going to be negative 1.2, and we got negative 2, and negative 1.2, and negative 2. All right. Now, the reason I had you get a highlighter out is I'd like you to highlight the actual cosecant graph. Usually when you're graphing cosecant, this sine curve I have in here, you don't leave in there. That's not part of the cosecant graph. That's the sine graph. However, you're using the sine curve to graph cosecant. So the points, the 0, the max, the 0, the min, the 0, those points are very helpful to you. But you don't usually see that other part. So that's the actual cosecant graph. Isn't that cool?
Yeah.
I know.
Should we erase it?
You can erase it. This is your note page. So if you want to leave it on there, that's fine. But when you're doing your assignments, I don't want you to leave it on there. So this is your note page you guys have. Any questions? That's amazing joy. Right now, the team that's in the lead in our class right now is this group. Make sure you choose your groups wisely. Okay? We are doing cosine now. I want you to graph cosine out to 4 pi. Okay, so remember on cosine you have max, 0, min, 0, and max. Okay? And so if we're doing that, in this case, A is 1, B is 1. So we're going to see one cycle from 0 to 2 pi. So we start with a max, we'll end with a max, and in between we have a minimum. And then we have our zeros in between those. So there we've got it. And this time, I'm not going to go all the way out to 4 pi at the beginning. I'm just going to go out to 2 pi, and then I'll continue it from there. Okay? So on this, actually, you know what? Let me change that. Let me actually put it out there. Okay. How many have that? How many actually drew the curve in? Okay. It's good to see the curve at the beginning. Just remember when we do our final graph, we won't see the curve. And that was really bad. Brooks, did you draw the curve in?
No, because I wouldn't. No, I didn't.
It's,
Drawing it now, though. Shut your mouth.
I feel like I'm racing Brooks.
Winning.
Did you win?
Yeah, I won.
Does your graph look as cool as mine?
Oh, it's way cooler because mine has asymptotes
Oh, no.
at the wrong spots.
All right. Speaking of asymptotes, why don't you tell your neighbor where the asymptotes are going to appear in this one?
You're over 2. Over 2.
Okay, volunteer. Yes, Jacob. Wherever the zeros are. Very good. Okay. So right here, use my pen. So when we're graphing secant, it's wherever the zeros are. Every time you see a 0, if you were to flip that, 0 over 1, it becomes 1 over 0, and that's an asymptote. So there's our asymptotes. Okay. You also, if you're looking at your table again, your secant, okay, you start seeing an undefined right here, and that's when cosine is 0. Every time you see cosine be 0, you get an undefined. Okay, so down here as well. All right. So you see at your maximum and your minimum when you have cosine equaling 1, secant equals 1. When cosine equals -1, secant equals -1. They share those points. But if we start just following down here, we got our 1, so that's that one there. And then we have our 2 root 3 over 3, which everyone knows as
1.2.
1.2. And then we have our 2. Okay. So we kind of get this half curve here. Remember, the cosine graph is a 90-degree shift of the sine curve. the cosec or the secant graph is a 90-degree shift of the cosecant curve. Okay? So we get -2, 1.2. So it's really the same graph you just did, just shifted 90 degrees. 1.2, 2. All right, so once you have the curves in, highlight them. I'm going to erase my cosine. Bless you. Oh, he
Yeah,
looks as serious about his sneeze.
I like to focus without being interrupted.
By sneezing?
But sneezing.
All
Sneezing
right.
is like my ultimate pet peeve interruption. Coughing, fine with. Sneezing, nope.
Sneezing's involuntary. Unless you tickle your nose with a feather. Then it's voluntary. All right. How do you think you got it? Any questions? All right, we have one left. What is it?
Tangent.
Tangent.
Cotangent. That's what I meant.
Cotangent. All right. Cotangent and tangent. I want you to now take your tangent curve and graph it from 0 to 4 pi. Okay? So get your other pieces in there. Make sure you're using pencil. You will have to erase on this one. I need to use pencil. Unbelievable.
Wait, 0. No, it's 0. 3.
Hey, what's the pattern? Noah.
0 max asymptote, min 0 max asymptote.
Okay, so 0 max. Well, not max, really. It's like your A, right? Okay.
0A asymptote.
Okay. 0A asymptote.
Negative A. 0.
Okay. Good. So we got that. All right. So we're going to plot this 0, our A, our asymptote. Now actually, I'm going by 4 lines there. How many cycles of this am I going to see between 0 and 2 pi? Riley says 2. Okay. Yeah. Remember, yeah, the number of cycles is 2b.
B is 1.
But then is it?
B, it's 2B, so B is 1.
B is 1.
Is it over 1 or 2?
A equals 1.
Over 1.
Okay, so that means I'm going to start at 0. At 2 pi, I'm going to have if there's 2 cycles, that means from 0 to 2 pi at pi, between 0 and pi, there's going to be 1 cycle. Okay, so I start with a 0, I end with a 0, in between there's an asymptote. And that means in between that asymptote and the 0 is our A. And then our negative A. Okay, and then from there we just keep following. So we're at A again. Some students like to just get in all the zeros and asymptotes and then put the negative A and positive A, and that works out really well for you as well. Oops, I'm too far down on that one.
Jared, I'm gonna need you to erase telephone.
You are correct. It is a telephone. No, that's fine. All right. Okay. Everyone have that?
Yeah.
We're good there? Okay. So on our cotangent, this one's kind of the weird one.
Cool.
When do you get asymptotes?
At 0,
When tangent is
0.
0. Same idea. So everywhere you see a 0, you have a new asymptote. Now, if you don't want to confuse yourself, put your asymptotes in a different color now.
I'll highlight the different asymptotes.
Otherwise, it gets really confusing, or make them a little longer than the other ones or something like that.
No, I did it wrong. It's fine. I'm gonna double highlight the ones
Using the double highlight. It's like double rainbow.
except. Okay.
There's a lot of asymptotes on this.
Dude, look at that. It makes a.
Look at all those asymptotes.
2, 3, 4, 5, 6, 7, 8, 9.
Holy moly.
All the asymptotes.
All right. Now, can anyone tell me, give me a volunteer, tell me where my zeros are for cotangent?
On the other asymptotes.
Good. Yeah. Where you see an asymptote for tangent, that's a 0. Think about it, right? Your 0 is whenever you have 0 over 1. That means your asymptote, so if for tangent I had 1 over 0, that gave me an asymptote. If I flip that, that's your asymptote. If I flip that, I now have 0 over 1 for cotangent. That's now a 0. Okay, so all these asymptotes you had for tangent now become zeros for cotangent. So you put a point right there. That's now a point for cotangent. That's now a point for cotangent. A point for cotangent. A point for cotangent. I'd say cotangent's winning now. They have a lot of points.
Nah.
No, I know.
That happened.
You coughing for Brooks?
Yeah. I'm not distracted by it, so it's totally fine.
So I'm erasing all these asymptotes. So I'm hoping you used a pencil. All those other asymptotes.
You care.
Okay. Now note, Megan, do you have a question? Okay. So you'll notice now if I look at this table, when I'm looking at tangent, notice cotangent's undefined when tangent's 0. Okay? When I look at undefined for tangent, my asymptote, cotangent's 0. We just established that. When you had root 3 over 3 for tangent, cotangent was root 3. Now stay with me. When I had root 3 for tangent, cotangent became root 3 over 3. So really what happened here is when I was going from here to here, okay, in my cotangent, when I start, now this isn't a 0, I'm starting from here and I'm going this way. They're going to share that A term. Okay? Now we don't actually see these points. Like if I go pi over 6, everyone do pi over 6 on their calculator. Or not pi over 6, I'm sorry. Do root 3 on your calculator. Oh, I have it right here. 1.7. I forgot. I have my cheat sheet right there for you. Okay, 1.7. That's actually right. That's right about there. Okay? Everyone do root 3 over 3 on their calculator. I don't have that one up here. 0.6? Okay. So root 3 over 3. So we've just plotted that one. Root 3 over 3 is 0.6. So that is right here. Actually about right there. Okay? Notice I have that 1 in between. What does that 1 represent? It's not on a line. That was one of my tangent points. That is your amplitude. Do I share that point with tangent and cotangent anywhere?
There is no amplitude for
Well, that's your A term.
Okay.
Yeah.
Different.
Yeah. Look at pi over 4, the ones we're not using for sine and cosine. Notice what those points are. They share those points. Cotangent and tangent, the common point that they share is your A term. Okay? So we could just use this A term here. Now I've actually added those other points. Okay, but it cuts through that A term, and I'm not going to add those other points every time. I'm just going to allow you guys to use the A term. Just kind of cut it through like that. What's that? Yeah, you got to make sure that you're able to erase, otherwise it really gets ugly. Now, if you're leaving all the lines on there and you're just highlighting because it's your note page, it's really going to look kind of confusing for sure. That's what your actual cotangent graph would look like. Here's what yours might look like on your paper if you left all the lines on there.
Yeah.
It's kind of like a mess. You see the tangent
Mine
curve,
is
but
like
the cotangent there is highlighted.
rainbow fun.
Yeah,
Look at mine.
yeah, that's pretty
I
neat.
even made a key.
Wow,
Everything.
geez.
This is handy.
Okay, how many think you got it?
That's not
That's what we're doing today. We're now done with day 2 of topic 2.
really.
We have 1 day left of it.